Have you ever stopped to think about the physics behind, well, everything that moves? Every single day, we are surrounded by this hidden world of pushes and pulls, of starting and stopping. Today, we're going to unlock the secret behind all of it. I want you to picture this. You're at the grocery store. You grab an empty cart and it just glides, right? So easy. But then, after you've loaded it up, suddenly you're wrestling this thing down the aisle. What's going on there? It's the same thing out on a soccer field. If you give the ball a little tap, it just rolls along. But if you give it a real powerful kick, it goes flying. You put more effort in, you get way more speed out. Now, these two things, they're not separate puzzles. They're actually two sides of the very same coin. And the answer? Oh, it's so elegant. It's not magic. It's not a trick. It's one of the fundamental laws that governs how our entire universe works. And the genius who figured all this out for us was, of course, Sir Isaac Newton. He basically wrote the rule book for motion, and his second law is the key that blows this whole mystery wide open. Now, what's incredible is that this law is universal. You're seeing it here in Arabic, but the idea is the same everywhere. Let's just break it down. Basically, Newton is saying that when you push on something, it speeds up, it accelerates. And how much it accelerates depends on two things. It's directly related to how hard you push it, but it's inversely related to how much stuff, or mass, that thing has. And Newton, being the genius he was, didn't just leave it at words. He gave us this incredibly simple, powerful little formula that describes it perfectly. This equation has been used to build pretty much everything from race cars to rockets. Force equals mass times acceleration. You know, we might be used to seeing it as F equals m times a, but the principle is identical in any language. So in Arabic, it's written as kaf equals kaf times ta. The symbols change, but the truth doesn't. Force equals mass times acceleration. Three little variables that explain almost all motion. So let's just quickly define our terms here. That first symbol, kaf, that's our force, the push or the pull, and we measure it in newtons. Next up, kaf is the mass, basically how much matter an object has, and that's in kilograms. And finally, ta represents acceleration, how quickly the object's speed changes, measured in meters per second squared. And this right here perfectly illustrates the two big ideas from Newton's law. On the left, you've got that direct relationship. The harder you kick a ball, that's more force, the more it's going to accelerate. Simple. But on the right, you see the inverse relationship. For that exact same kick, if the object has more mass, like our full shopping cart, you're going to get less acceleration. Okay, theory is great at all, but let's see how this law actually works in the real world. Let's get our hands dirty and actually use this formula to predict something. All right, here's a classic physics problem for you. Let's imagine you have an object, maybe a box, and it has a mass of 5 kilograms. Now, if you push that box with a force of 30 newtons, how fast is it going to accelerate? So how do we figure this out? It's really just a simple 3-step process. First, you always start with the formula. Then you just plug in the numbers you already know, 30 for the force and 5 for the mass. Now, to find the acceleration, all we have to do is a little bit of rearranging and divide the force by the mass. And there it is. The answer is 6 meters per second squared. So what does that actually mean? It means that for every single second you keep pushing, that object's speed will increase by 6 meters per second. That is the incredible predictive power of Newton's second law. Okay, so let's bring it all the way back to our shopping cart. The push you give it, that's the force. With the empty cart, you have a low mass, so that same push creates a high acceleration. It just zips away no problem. But with the full cart, now you have a high mass, so that very same push results in a low acceleration. You have to push way harder just to get it going. And just like that, mystery solved. So, we figured out the shopping cart. But this law isn't just about everyday stuff. Its real power is how it scales up. I mean, way up. It explains motion on a much, much grander scale, from incredible engineering feats to launching missions into deep space. You see, our world is just governed by forces. Some of them you have to touch, like pushing or pulling, but others, like gravity or magnetism, can act over totally empty space. Newton's second law, it's the universal tool that scientists and engineers use to understand and predict what all of these forces will do. And this is where its power just becomes so obvious. Engineers use this law every single day. If you want to make a race car faster, what do? You lower its mass. If you want to build a bridge that's safe, you have to calculate all the forces on it to make sure its acceleration is zero. In other words, to make sure it doesn't move. And to get a rocket into orbit, you have to calculate the unbelievable force needed to accelerate that huge mass against the pull of gravity. And get this, here's a really cool one. Ever wonder how a karate expert can shatter a solid brick with their bare hand? It's F equals ma in action. They move their hand incredibly fast, which creates a huge acceleration. And even though their hand has a pretty small mass, that massive acceleration generates enough force for a split second to completely shatter the brick. So, after all that, what's the one thing you really need to remember? What's the bottom line here? It really just comes down to this simple story. A force acts on a mass, and the result of that interaction is acceleration. A push moves some stuff, and that causes its motion to change. That right there is the heart and soul of Newton's second law. Let me just put it one last time in the clearest way possible. An object's acceleration comes down to just two things: the total force pushing on it and the mass of the object itself. That's it. Nothing more, nothing less. It's a perfect relationship that holds up our physical world. So, the next time you throw a ball or push open a heavy door or even just feel your own weight in a chair, you'll know the rule that's making it all happen. So my question to you is, now that you know the secret, where are you going to see F equals ma next? Thanks for listening.